So now, as we know, yesterday I have told you, except monoatomic elements, no other elements can exist independently. So always they will be exist as a, like more than one atom will be existed together. So except monoatomic elements. So what is the monoatomic elements? Example, everyone. Monoatomic elements example is what? Everybody?
Yeah.
Noble gases. Yes. Noble gases. So noble gases are, we can say, unreactive gases. Unreactive gases. So these are the gases which are inert gases, which are stable in nature, will never react with any other substances. So, but if you take another elements, of course, we have many elements. So, other than these monoatomic elements, remaining all, they are basically, they are unstable in nature. So, to become stable, they always existed in the form of molecules, or they will be existed in the form of what? Everybody? In the form of ions. Clear, everyone? So either they existed in the form of molecules or they existed in the form of ions. As I said yesterday, if it is molecules, again molecules are two types. Can you tell me what is that, everybody? Either it is a
Molecules of element.
yes, either it is a molecules of elements or it is a
Molecule of compound.
molecules of compounds. Molecules of compounds. But if it is ions, only compounds will come. What is that compounds, everybody? They are ionic compounds. What compounds?
Ionic
Ionic
compound.
compounds. Clear? Now, let us start with the molecules now. So we are going to study what is molecules and how it will be, everything. As I said, atoms are electrically what? Everybody. What is the charge of an atom? Overall charge. Positive or negative or neutral? Everybody?
Neutral, sir.
Neutral. So, atoms, if you take any kind of atoms, please remember, number of protons. Number of protons means what charge? Positive charge or negative charge? Positive charge. And number of negative charge, that is what electrons, is equal. So, overall charge, if you have taken overall charge of an atom, which is equals to 0, or the net charge of an atom is 0, because amount of positive charge is equals to amount of negative charge. That's why we can say atoms are electrically neutral. And molecules also electrically what? Neutral. But if you have taken ions alone, ions, maybe protons are more or electrons are more. If protons are more, we can say they are positively charged ions. If electrons are more, we can say they are negatively charged ions. Do you understand, everybody? If number of protons are high, we can say positively charged ions. If number of electrons are high, we can say negatively charged ions. Do you understand it? So that is why we can say ions are neutral in nature, or electrically they are charged particles. Everybody, they are electrically
Charged.
they are electrically charged particles. Understand, everyone? Clear, everybody? Now, the most important point I'm going to say you, this is extremely important for entire chemistry. Forgot about the molecules of elements. Molecules of compounds will form by sharing of electrons. What is that, everybody? Sharing of electrons. Please remember. Okay. So each mutual understanding between the elements, atoms of an elements will form the molecules of a compounds. Are you clear, everyone? Please respond. Understand, Amma? Now, ionic compounds will form, very, very important. Ionic compounds will form by donating and accepting electrons. Donating and accepting electrons means completely one will lose the electrons and completely one will gain the electrons. I hope you all understand. Everybody clear? Completely one will lose the electrons, completely one will gain the electrons. That is what? Donating, who is going to lose the electrons, we can say donating electrons. Who is going to accept or receive the electrons is called it as a receiver. Donor and receiver. So that is what ionic compounds. Please remember everybody. By donating and accepting electrons, ionic compounds will form. By sharing of electrons, molecules of compounds will form. These molecules of compounds, we used to call it as a covalent compounds. What is the compounds we used to call, everybody? Covalent
Sir,
compounds.
both molecule of element and compound is known as covalent compounds.
No. Molecules of elements sambandhame illa mari. That's what I'm saying you. Molecules of elements is a pure same particular element. I'm talking about compounds. Clear? Clear? Compounds are two types, Mari. Remember your book class 9th, entirely ionic compounds are there, covalent compounds also there, we'll study. So compounds are two types. You are having it. One is covalent compounds. Another one is what?
Ionic compound.
Ionic compounds. Am I understanding? One is covalent compounds. Another one is what? Ionic compound. Covalent compounds will form by sharing of electrons.
By sharing of electrons.
Ionic compounds will formed by donating and receiving electrons. Do you understand, everybody? All of you? Covalent compounds by sharing of electrons.
The protons and neutrons will not involve in the exchange of
Yes. No chemical reaction will take place by donating or receiving of protons. Only who will involve in the chemical reaction? Atoms. In that atoms, who will involve in the chemical reaction? Electrons.
electrons.
Only electrons. Because the moving charge is only electrons. The protons and neutrons is always tightly binded in the nucleus. So they are not moving, they are not revolving, they are not involving in any reaction. Only electrons are involving in the chemical reaction. Are you clear, everybody?
Yes, sir.
That is what. So please make it. Any doubt you can ask. All of you clear? Yes. So the best example for covalent compound, if you take, for example, methane. Methane is the best example of covalent compound. Ionic compound, the best example of sodium chloride, NaCl. What is that? NaCl. Sodium will give one electron. Sir, why, sir, it will give one electron? To become stable. Chlorine will accept one electron. Sir, why, sir, again it will become accepting one electron? To become stable. Why they want to become stable? Because they wants to be, basically everybody wants to be stable in nature. If you are unstable, by somehow, by losing something or by gaining something or by sharing something, you want to be attains the stability like monoatomic compounds, monoatomic elements. That is the purpose. Entire chemistry is there. Chemistry is only because to attain, atoms wants to attain the stability, elements wants to attain the stability. That is what is chemistry. So ionic compounds means, I will explain you, don't worry, first listen. One donor will be there, he will donate the electron, and one receiver will be there who will accept the electron. That is what we used to call it as a ionic compounds. So here sodium will completely lose the electron. Chlorine will completely accept the electron. That is what ionic compound. Now here, carbon. Basically, carbon need 4 electrons extra. Why means I will teach you. Don't worry. First, on example alone, I'm saying. So it will form sharing. It will share its 4 electrons with the 4 hydrogen atoms. 4 hydrogen atoms. So that is how the methane will form. So if 4 hydrogen atoms, they are sharing 4 electrons with the carbon, and carbon also sharing 4 electrons, 1 electron each with the hydrogen. That is how methane is forming. So here sharing of electrons is taking place. Here donating and accepting of electrons is taking place. That is why this is ionic compound and this is a what compound? Everybody. Yes, please. Covalent compound. Clear?
Sir,
Yes.
in CH4, sharing of electrons is taking place, sir.
Yes. CH4 sharing of electrons. That is why it is a covalent bond, covalent compound. Okay. Once you will
Yes.
study the valency, you will understand this entirely very in detail. You just wait. We are going to study ions.
Sir, one doubt, sir.
Valency. Yes.
Sir, will Cl also donate 1 electron or accept 1
No,
electron?
Cl only will accept. Sodium only will donate.
Yes, sir.
Okay. We'll study class 9th you have. That is only very important concept in this chapter. In this chapter, you are going to study that is only mainly. So we'll discuss it. Don't worry. Okay.
Yes.
So now, this is what is the types of compounds. Now, let us start our today's class. As I said, molecules. So molecules are 2 types. What is that? Either it is the molecules of an element or the molecules of an compounds. Okay. So let us make it everybody. First, molecules of an elements. Keep reading everybody. Molecules of an element. Molecules of element. Okay. So write it. Same kind of atoms joined together. Same kind of atom. Same kind of atoms joined together to form molecules, and they are called, what is to call everybody? Molecules of the element are compound are same kind. Same kind means what? Everybody. Same kind means what it is? Same kind means it is the element. Molecules of an element. Same kind means molecules of an element. Please note it and remember that. Any doubt anybody having? You can ask me. Are you clear, everybody? Alfin, Abhirami, Rasni, Gokul Raja, are you there? That is what. Now, if you have taken all the atoms in the molecule, they are the single type or same kind. Same kind or single type. They are called it as a molecules of an element. Please note it. And this molecule of an element, same kind, is called it as a homoatomic molecule. None can knows this all. Only people will study, just we can say one minute or 2 minutes, that's all. But this is a very basic foundation of a chemistry, extremely helpful for us in higher classes. You will understand the importance of it when you are coming to the higher class. Yes, Mar, tell me.
Then in whole, the molecules of elements, can we call it as homoatomic?
Yes, molecules of elements, we can say homoatomic molecules. Okay.
Yes.
Because same kind of atoms are present. That is what we used to say molecules of an element. Clear?
Yes, sir.
That is. So now, examples. The best examples you can see, you can form. I will show you. First, 2, if it is there. So what is that also we can say. So of course, no atom will exist independently, but sodium and all will represent normally. But here you can see that. So this is the best image also. I will send you. Can you able to see the screen, everybody? All of you?
Yes.
No other book or nowhere you can find this image also. You can notice it. Of course, we'll study this. So all of you observe here what it is saying. Hydrogen. So hydrogen, you can see elements that exist as a diatomic molecules. That is the types of it. We'll study. Don't worry that. Okay. Elements that exist as diatomic molecule. Elements, they exist monoatomic also. Can you give me the examples? Who can exist monoatomic?
Noble gas.
Noble gases. Super, Amma. Very good. If you write sodium, potassium and all, it's wrong. Do you understand, everybody? If they'll ask you example for monoatomic, if you write sodium, potassium, calcium and all, they are what? Wrong. Of course, calcium is 2. If I write sodium, sir, I am writing only one correct, sir. Potassium, magnesium, aluminium, zinc. We are writing as a single, but millions of atoms together. Millions of atoms together. That is why you are not supposed to write examples of this is for monoatomic molecules. Are you clear what I am saying, everybody? Monoatomic molecules means people will think these are also examples for monoatomic molecules, but nothing, these all are not call it as a monoatomic molecules. Understand, Ra? Everybody, Mr. Sam, girls, Agalya.
So can we call it as homoatomic molecule?
Yeah, they all are actually more atoms. There is no number. That's why we can say they are actually polyatomic molecules. Monoatomic means only single atom has to be present. Who is existed independently without depending on anything?
Noble gases.
Noble
6
gases.
noble gases.
Yes, monoatomic gases. That will come at this point. 18th group of our periodic table. So this is what we used to call it as a noble gases. Helium, neon, argon, krypton, xenon, and radon. Okay.
So that's it.
Yeah.
So that is different, sir.
Yes. Huh? Yes, Mari?
So below that another one will also come, sir.
But by that time, this is still the properties is not studied. Do you understand? Just they have been placed. We don't know the exact properties of these elements till today. That's why we won't consider. Clear? Still under research. Now, you can notice it here. Diatomic molecule. Examples I am saying. What is the molecules can occur free state as they are stable in nature. Free state, they are stable in nature. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, sulfur, phosphorus. These all are examples of what? Molecules of an element. What is that? Molecules of an element. Of course, even O3, ozone, O3, that is also examples of molecules of an element. Do you understand what I am saying, everybody? Clear? Please respond. So these all are the examples of molecules of an elements. But you can see, notice it here. Here only single bond I have drawn, but here triple bond, here double bond, here again single bond, single bond, single bond, single bond. Now you don't understand that. After I am teaching the valencies, you will understand it. So you no need to worry, you just wait and you remember. So these all are the examples of what? Everybody?
Homoatomic molecules.
Homoatomic molecules. Okay? Clear? Understand now? Clear? Everybody? So now, these atoms, have you noticed it? Here hydrogen I am saying only 2. Nitrogen also 2. Oxygen also 2. Fluorine 2. Chlorine 2. But sulfur 8. Phosphorus 4. This is what we used to call it as a atomicity. What we used to call, everybody? Atomicity. Okay? Most important definition in chemistry. The number of atoms present in a molecule. Purima, Adi, that is a molecule of an element, molecule of a compound, doesn't matter. Total number of atoms present in a molecule is called it as a atomicity. Okay, write the definition. Do you understand this image, everybody? Are you clear, guys? Yes, please. All of you.
Sir, but these are also examples of molecules of elements.
These all are molecules of elements. Molecules of compounds is different. That I will show you. You wait.
Yes.
Clear?
Yes, sir.
These all are examples of what, Amma? Molecules of elements only. Clear, Amma?
So sulfur and phosphorus can be taken as examples of homoatomic molecules,
Yes, they are more number.
but they are also polyatomic.
Their polyatomic means more than 2, more than
Yes,
3.
sir.
That's all it is. Nothing is there. Clear?
Yes, sir.
Understand? Clear?
Yes, sir.
Everybody, that is what. Write it. All of you. Examples. What is the examples, Amma? Molecules of an element. What is the examples? O2, O3, P4, S8, and you can take N2.
So what is meant by atomicity, sir?
I will say you. These all are the examples of molecules of an element. Please note it, everybody. H2, Br2, I2, iodine. These all are examples of molecules of an element. Okay, everyone? Clear, everybody? Yes, please. All of you clear?
Yes, sir.
Yes. So make it quick. Any doubt you can ask me. Kavya, understand Kavya? Agalya? Shivani? Yes. Now, atomicity. Write the definition first. The number of atoms present in a molecule is called its atomicity. So now, based upon the number of atoms of elements, we are classifying into varieties of types. In that, the first one is monoatomic. What do you mean by monoatomic? How many?
Noble.
Yes. So monoatomic, only elements which are stable. So
6.
elements which are stable in nature, which are stable and do not react easily are found in monoatomic form. Are you clear, everybody? Suppose if I take sodium, is it a monoatomic? Potassium, monoatomic? Everyone? Please respond. Sodium, potassium, carbon, fluorine, these all are monoatomic. I'm asking you.
No, sir.
No, they all are reactive elements. The reactive elements, the symbol is taken as a single, but does not mean that it is a single atom. It is the group of atoms. So that is why unreactive elements alone we used to consider as a monoatomic. This point, majority of the people don't know even. Many people, they will write exam, sodium, potassium, also example of monoatomic. So monoatomic means only elements which are stable, which do not react. That is what you have to remember. So what is the examples, everybody? What is the examples? Noble gases.
Noble gases.
Yeah, that is what. What is the examples? Helium, He. Just you write one thing. Neon, Ne, argon, Ar. So on, you can write it. No problem in that. Okay. What are these diatomic? Which is Abhirami? What I have shown you?
No, sir, that sodium, chlorine, that and all, sir.
They all are polyatomic. Many atoms together. Cluster of atoms there. Clear?
Okay, sir.
Yeah, there large number of atoms are together. So we can say them as a like a giant molecules. They are very big. But representation will make it normal. Clear?
So this is known as monoatomic elements.
Monoatomic elements or
Yes.
molecules of elements, whatever it is. Okay?
Yes.
Well, understand, ma? Alphane. Second one, diatomic. Diatomic means molecules in which atoms are found in what? Everybody. Atoms are found in how many? Only 2.
So diatomic, can we say it as homoatomic?
No, they all are homoatomic, Mari. Not mono, homo. Everything is mono only. See, homo means same atoms. Adi one erika, rendu erika, moonu erika, prachane illa Mari. Everything is a homoatomic. Clear?
Yes. Yes, sir.
Yeah. Same means homo. That is what it is. You have to remember. Clear?
Yes, sir.
Yes. So diatomic means molecules in which atoms are found. Atoms are found in pair. In pair called diatomic molecules. Clear, everybody? What is the examples? What is the examples, guys? Nitrogen, oxygen,
Bromine.
chlorine, hydrogen. Enough, you can. Okay? Any doubt, you can ask me. So if you want to draw it also, together they are present.
So that's OL3 only, no, sir.
O2, oxygen.
Yes,
O3, adi different. Clear?
yes.
Ozone, adi ozone. Is O2, O and O. Okay?
Yes, sir.
Yeah. Any doubt for anybody, you can ask. These are the examples of what? Examples of diatomic molecules. Understand all English? Mukesh Kalyan, are you doing? Don't know what doing also. Yes. Simply namesake not. Listening this year and leaving that year is not going to work out. Very seriously do it. Okay. Next. Triatomic. Write it. 3 atoms combined together. 3 atoms combined together. 3 atoms combined together. 3 atoms combined together to form triatomic molecule. Clear, everybody? Understand, everyone? So tri, of course, more than 2 we can say poly, but of course we can write. So triatomic. So triatomic means how many atoms, everybody?
Boson.
Yes,
3.
3 atoms. 3 atoms. Same atoms or same kind of atoms or different kind of atoms? That is very important.
Same kind of
Same
atoms.
kind. That is for what? Molecules of an element. Do you understand, Mari? If it is a compound, 3 different atoms also. That's why I'm not mentioning same. Clear?
Yes.
Yes. Atomicity is for everything. Molecules of an element, molecules of a compound, whatever it is. For example, H2O, what is atomicity? 3 only. 2 hydrogen atoms plus 1 oxygen. Atomicity is 3. Do you understand what I'm saying, guys? All of you. But it is a molecule. Molecule of a what? Compound or element? H2O. H2O is a what? Molecule of a compound or element? Everybody.
Compound.
Molecule of a compound.
Compound.
Atomicity is 3. If I take O3, ozone, it is a molecule of an element. What is atomicity? 3 only. Do you understand? Yes?
Yes, sir.
Yes, that is what. Right. Ozone. Triatomic. 3 atoms combined. 3 atoms combined together to form triatomic molecule. Any doubt anybody can ask. Next. Tetraatomic. 4 atoms.
Sir, is it tetra or tetra?
Tetra. T-E-T-R-A. Tetra. Atomic, 4 atoms combined together. What is the example of tetra? Already I-
Phosphorus.
Yes. P4. Phosphorus. Clear, everybody? Understand, all of you? So you can notice it here. Phosphorus. Phosphorus, P4. 4 molecules of phosphorus together. 1, 2, 3, and 4. 4 molecules of phosphorus together. 1, 2, 3, and 4. Okay, wa? Understand?
Sir.
All okay? Yes. Do it. Any doubt you can ask. Again, 10th class also carbons compounds, you might get these structures. P4 and S5, S8, sulfur. Next, polyatomic. Polyatomic, right? When more than 4 atoms are combined together, more than 4 atoms combined together, more than 4 atoms combined together to form what? Everybody, molecule of an element or molecule of a compound? Molecule of an element. Okay, molecule of an element is known as polyatomic molecules. Polyatomic, polyatomic, polyatomic
element.
Element. Clear? Any doubt?
No, sir.
Okay, clear everybody? Understand? Yeah. More than 4. 4 already I have given you. 4 means what is the name I have given? Tetraatomic. Am I right or wrong? Yes, please.
Yes, sir.
Yeah. 4 means already I have given tetra. More than 4, I can take it as a poly. That's all it is. Now, examples for polyatomic. In front of you, one is there. What is that? S8.
Sulfur.
Yeah.
Sulfur.
Sir, can we take it as SULPHUR?
Sulfur. No. Sulfur spelling adida mari.
Sir, but
Okay, PHUR also correct one. You can take it. But actual name is SULPUR, FUR only mari. Is there
yes, sir, yes.
PHUR? Okay. S5 also can be existed. S5 also, you can write it. Sulfur S5 also is example of polyatomic. Clear? All of you?
Yes,
Everybody
sir.
understand? Now, I want to show you one more thing. That is very important. That is what C60. You can take not only C60, you can take allotropes of carbon. So allotropes of carbon, they are actually more in number, like diamond, graphite, and fullerenes. So these are called it as, these three are called it as allotropes of carbon, there are hundreds of macro molecules. These are called it as. There's a cluster of atoms are present in this. So they are called it as a giant molecules. Please note it. This is the last one. The molecules of some elements have large number of atoms. Large number of atoms. That is what we can say cluster. Cluster of atoms. And they are called it as a macromolecules. Macro means big.
So large number
Macromolecules.
of
Large number of atoms. Large number of atoms. Macromolecules, or we can say giant molecules. Examples, these three: diamond, graphite, and Buckminster fullerene, which is formula is C60. What is the Buckminster fullerene formula, everybody? C60 means 60 carbon atoms together. Carbon atoms together. That is what we used to call it as a Buckminster fullerene. Clear, everyone? All of you?
so